we're solving problem 19 from the Spring 2021 AMC 12B. Two fair dice, each with at least 6 faces, are rolled. On each face of each die is printed a distinct integer from 1 to the number of faces on that die inclusive. The probability of rolling a sum of 7 is 3/4. The probability of rolling a sum of 10 and the probability of rolling a sum of 12 is 1/12. What is the least possible number of faces on the two die combined? So, for this problem, well, let's just look at the third statement. Probability of rolling a sum of 12 is 1 in 12. So then, well, if we have two such integers where we assume A is greater than B, greater than or equal to, A plus B will be 12. And in the first case, for a die 1 to 6, it will be one solution. So 6 plus 6 equals 12. But then when you keep on adding more and more faces to the die, more solutions will appear. So 7 and 5, for example, 7 plus 5 is 12. That's when you have more faces on a die. So now the question is, how can we express this? Well, expressing the probability to be a 1 in 12, well, let's just if we sum the two faces A and B, and then subtract 11 from it and divide it by A and B, we will see that this results in a 1 in 12. Because we know that this has to be a 12 out of 12, 1, and then divide by, and then this is actually multiply, so AB. So we have this equation. We can multiply this out, 12 times 12 on both sides, and AB on this one. 12A plus 12B minus 132 is AB. We notice that 132 is 12 away from 12. So we use Simon's favorite factoring trick to get this down to A minus 12 times B minus 12. But there's that 12. We need it to get to 132 back. So in order to get it back to 132, you have to subtract another 12 at the end or add it over here. It then goes for this system of equations. So then we get a few solutions. A and B could have the dice in 13 and 24, 6 and 10, and 8 and 9. Right away we see that 13 and 24 faces are not correct. We want the least possible number of faces of the two dice. Now 6 and 10 does have a less number of faces, but we want the probability of rolling a sum of 7 is 3/4 the probability of rolling a sum of 10, where in this case rolling a sum of 10 is impossible because one of the faces is 10 and the least you can roll on the other die is a 1, so that one's out. Therefore, we have our only option left, 8 and 9. And in order to test this, we can set the equation equal to each other by equating it. So 6 over 72 is 3/4 that of 9 plus 8 minus 9, and then divide by 72. Now, for this equation, well, it would be actually correct. So we then see that 8 and 9 is our A and B. So the sum of 8 and 9 is simply 17. So 17 is our answer.